We are going to start our discussion of time value money with a very simple present value, future value relationship. All right, and so we're going to talk about first, before we start getting into things, we've got a formula that we've written down, and we're going to look at, what these little components of this formula mean, what these letters represent, before we can talk about what the math is trying to tell us. So we've got a PV that stands for a present value. That is typically a value of money or an asset or something that is immediately changing hands. Then you've got FV, which is a future value. Now, because that's in the future, it can happen at any of multiple points in time. And so we've got the little t, and the t here just is to tell us at what time this future value transfers, okay? And it also appears here in this part of the formula. Now, I will say the subscripts do not really have a mathematical purpose. They're just a notational device so that we don't forget what time period these values are being exchanged. And then you've got the R, that is our discount rate or required rate of return or an interest rate, or it's got a lot of different names. It simply represents the rate of change in value throughout time. And so we also have an exponent on this term, and that is also its t, and it's because we use that period of time as a measure of distance. How far in the future is this value occurring? Now, while this subscript does not have a mathematical purpose, the exponent absolutely has a mathematical purpose. All right, so what this little formula is telling us is that if you want to know the value today of some transfer of money or value in the future, it's not going to be the same number, right? And so that means, if I am going to receive, say, $110 in 1 year, and I want to know how much is that money worth to me right now. Again, it's not that I will have the money right now, but I want to know what is that equivalent value right now. Or, a different way to look at this is, if I want to give up some money right now so that I get $110 back in 1 year, how much money should I give away right now in exchange for that promise of $110 a year? Obviously, I am not going to give somebody $110 right now just so I can get the exact same value back in the future. That would be a really poor use of my money, because in the meantime, I don't have it. And so I'm going to require that they give me back more money in the future than I give them today. So how do we know what's appropriate? Well, we've got to know what the rate of change in value is over a course of time so that I can tell you that appropriate exchange. Now, that's where the R comes in and the T comes in, because that T tells me how far away that value is, and the R tells me how much value changes throughout time. So again, let's say that we're 1 year out in the future, and let's say that the interest rates in the market are 10%. Well, that means R is 0.1 or 10%, and I add that to 1, so I get 1.1, and my T is going to be 1 because I am 1 year out in the future with this value. Well, that means the equivalent value today would be equal to $100. And what we would say is, hey, if you give up $100 right now and let me use your money for a year, in a year, I'll give you back $110, right? And if interest rates are 10%, then this would be a fair deal. Nobody's really getting a deal, a benefit. It's just, hey, that's just what's going on in the market. And so that's the basics of how to do a present value, future value relationship. But now this formula, because it's an equation, means that we can rearrange it. And so it is just as true to do it this way and say, okay, well, if I am willing to give up a value today and leave it in someone else's hands for a period of time, how much in the future should I expect to receive back whenever they pay me back, right? And so again, it's the same formula, but it's just rearranged so that now I can solve for a future value. And so we use the same formula. And now this piece tells me how to take a present value and turn it into a future value, whereas this formula told me how to take a future value and turn it into a present value, right? And so it's the same math. And so if I say, well, if I'm willing to give up $100 and market rates are 10% and I give up my $100 for 1 year, well, in a year, I should expect to receive $110 back on that investment. And so that would also be a fair deal. And so this drives home one principle that in most financial transactions like loans or investments, it involves giving up money at some point in exchange to receive money back at a different point. Now, if we do that in reverse, if we receive money today in exchange for giving up money in the future, we call that borrowing money, right? So in this example with this math, you could say, hey, if you want to borrow $100 today for 1 year and your interest rate is 10%, in the future, you're going to have to pay back $110. Now, for every borrower, there's a lender. From the lender's perspective, it's the exact same transaction, they're just on the other side of it. So if you're a lender and you're willing to give up $100 today and let somebody else have it, and you're going to earn a 10% return on that money, 10% rate of interest, then in the future you can expect to receive $110 in 1 year, right? And so it's the same math from both perspectives. You just got to think, okay, well, am I needing to borrow money or am I lending money, and which end of things am I going to be on? And then you're going to set your target. Am I trying to decide based on a future value and determine what an equivalent present value is? Or am I trying to figure out from a given present value what the equivalent future value is? And then you can go back and forth through time using this formula. Now, if we take this little setup here, right, and so we're going to look at this, and let's say that this was a standpoint that you were the investor and you gave up $100 today, and so you left it alone, and in 1 year you were going to get $110 back. But you say, hey, I don't want to do that. I actually want to lend that money out for another year, or just let that person keep it for another year. Well, what would happen? Well, this is where you can say, all right, well, in that case, the $110 begins the next year, because at the end of 1 year, you were owed $110. Well, you never got paid, so that just rolls forward. Well, if you let it go for another year, right, so we let that 10% happen for 1 more year, at the end of the next year, well, you're going to have $121 owed to you. Okay, now, this is equivalent to taking $100 and leaving it invested for 2 years. Okay, and so that's where that T becomes handy, because that just lets us do the compounding all at once. Instead of having to do a sequence of multiplications, we can just take the exponent, and that exponent says basically how long until you receive your money. All right, and so every time period that passes, we're getting another 10%. And if we just want to let it roll on, there you go. All right, and so these two expressions, right, either going $100 at 10% 2 years consecutively, or just jumping straight through 2 years with an exponent, it's the same thing. And so this is a very important mathematical principle that we're going to use a lot. Now, the next thing to point out is functionally, what we've got at the end of a year, right, is you get your $100 back, plus you get 10% interest, which is the other $10. This is equivalent to, well, you get your $110 back, plus you get an extra 10%, which is another $11. Now, if you notice, you're getting $100 back. You're going to get 10% on that $100 during the first year. In the second year, that $100 earns another 10% interest. And since this $10 was in there from the end of the first year through the second year, it gets 10% interest. And so this is compounding, right? Where you don't just get interest on the original investment every year, you also get interest on the interest every year. And so this piles up over time, and that's why investing over long horizons is so powerful for saving money and so costly whenever you're borrowing money.